All right, good morning. It's Mr. Nelson. We're back. It's Wednesday, May the 6th, and we are getting introduced to our final unit, light, and specifically today we're going to explore light as a wave. And the question you're going to have is, how are light waves similar? How are they different to sound waves? There's a little discussion to start, which asks you to read the first three sections of chapter 26 on light waves specifically. Light behaves as a wave often and as an electromagnetic wave. You've probably studied the electromagnetic wave spectrum, EM spectrum. Read through this, take good reading notes. There's going to be a short little quiz on this later. Pretty simple. Check off the box when you're done. And then in the discussion today, discuss how light waves compare and how they contrast to sound waves, and list at least two similarities and two differences. There's a set of mastering physics reading questions to accompany that. The good news is that all of the information that you have studied already, or as it relates to waves and wave behavior, applies to all waves, including light waves. And you'll see some references to the EM spectrum, like this one that has the wavelength of light, the frequency of light. And if you go through these different spectrums, you might notice that while we have visible light, here's the type of light, visible light, that we can see with the human eye between 400 and 700 nanometers, but there's a lot of light we can't see: ultraviolet light, X-ray light, gamma rays, infrared light, microwave radiation light. You guys actually studied microwaves a little bit with your microwave lab. And radio waves, lots of families of radio waves. The visible spectrum is often broken down into colors, and some of you may have seen the red, orange, yellow, green, blue, indigo, violet, Roy G. Biv colors of the rainbow. And if you play around with a couple of these applets, you'll see some of these are in the reading. It's obvious that as you move towards the red end, the wavelengths get longer and longer. And as you move towards the blue end of the visible spectrum, the wavelengths get smaller and smaller. And just like we studied before, a smaller wavelength corresponds to a higher frequency, whereas a longer wavelength corresponds to a lower frequency. And that's true of all the waves, not just sound waves and mechanical waves that we've studied, but this is true of electromagnetic waves or light waves. Take some time in the reading, take some time with the mastering physics, explore some of the applets you may see in your connected to your reading. A couple of these applets that I'm showing you right now can also be found as you open up the final unit folder, Unit 8, Light and Color. As we begin the light unit, there's a couple little applets here. And on that note, good luck until next time. Wishing you all well, and I will answer any questions that you have related to this material, and we'll keep exploring Friday. All the best. Bye-bye.